Hi, I'm Treynor Sloss. I'm the Vice President of 24/7 here at Google, and I'm here today to talk to you about reliability in the cloud. Leveraging cloud allows customers to achieve outcomes of scale, reach, speed, and flexibility, which would be difficult or impossible to achieve for many companies and many services. For this talk, I'm going to focus on reaching high levels of reliability for services running in the cloud. Here at Google, we've been building extremely reliable services in the cloud for 2 decades now. And along the way, we've learned a lot about what works well, and we've also found some pitfalls that we're going to help you avoid. Cloud offers a lot of power and a lot of options for building reliable systems. And that flexibility is great, but it also means the cloud offers some new and interesting ways to get reliability wrong. And because public clouds work differently than many traditional on-premise data center environments, the reliability paradigm that works well in cloud is also somewhat different from a traditional setup, and we'll cover that. So today I'm going to give you a framework for understanding your reliability goals and how to achieve those goals in the cloud. I'll cover 3 distinct topics: defining requirements, choosing an architecture and design, and implementation and execution and deployment. This talk is adapted from Google's own internal best practices for building and maintaining cloud-based systems, and we use those same practices to implement both customer-facing products like Search, Gmail, and YouTube, as well as our own cloud infrastructure. So first, you need to define business requirements for reliability. And I want to emphasize how important this step is. This is the requirement stage for reliability. And we all know intellectually that getting requirements just so is critical before you proceed to design and implementation. But we also know in practice that sometimes we don't spend enough time on requirements. And that can be especially true for a requirement that seems a little soft or squishy, like reliability. So when we talk about reliability, often the temptation is to say our reliability requirement is 100%, or it always works. Or we assume that the infrastructure provider is going to be perfect, right? And that turns out to be close, but not actually the correct reliability target. So the outcome of this exercise will be reliability requirements and targets for you to use, along with a way to measure them. So this slide is critical. It is, the central idea behind our approach to reliability. And this comes from our own experience, right? What we find is that there is a sweet spot for setting a reliability target which balances between the 2 basic considerations that we have in reliability. The first is user expectations, right? If your product is insufficiently reliable, you select too low a target and you deliver that target, your users will not like your product and they will eventually leave you for a competitor. And everyone pretty much understands this, right? A product that simply doesn't work most of the time is not going to be a great product. But what we don't understand quite as often is that if your product was perfect, if it delivered 100% uptime, your user's experience will still be far from perfect, right? Because there are lots of sources of unreliability in the end-to-end chain that your user experiences, right? Their device may not work. If you have a mobile device and it malfunctioned 1 time in 1,000 when you were trying to reach some site, you would say that's a very good, very reliable mobile device. Yet that's only 3 nines, right? And so if your users can't tell the difference between 3 nines of availability and perfect availability, then the user benefit that you get from making your application far more reliable is de minimis. But part 2, the cost of reliability, right, goes up exponentially as you approach perfection. And so you can see on this chart this basic idea, right? As reliability approaches perfect, the user benefit becomes nearly 0 and the cost rises exponentially. And so the perfect target for reliability, which balances the cost in terms of both direct dollars and your development velocity of reliability and the marginal benefit of increased reliability, turns out not to be 100% for your application, but rather a number that's very close to 100%. very common number is 99.95% availability up to 99.99% availability, simply because the other systems that are in between you and your user typically are not more reliable than that to begin with. And picking this target, which is just shy of perfection, both keeps your costs way down and also allows you the ability to develop new features and new functions for your users much more quickly because you're spending less engineering time on working on perfection. And in practice, that ends up being a good choice for achieving user happiness. So when we look at reliability, in addition to this idea of picking a conscious choice that's a bit short of perfection, the other thing that we find is that it's really important to do the reliability exercise in a coordinated way across your different teams, right? This allows you to make decisions about the reliability of product components that support the user actions that they're taking with your application. And here in turn, right, not all user activities have the same requirements for reliability, right? And for your business or for their value, different activities have different expectations. And that, again, is an opportunity for you to strike a more cost-efficient and appropriate balance on the whole for your users and for your application, instead of holding every part of your system to the same high watermark of the most critical user activities. This approach also helps you avoid unexpected and unwanted uneven behavior of your application, where some parts work very, very well, maybe more well than you need them, and other parts disappoint your user because they don't work as well as it's required. So let's talk about how to define this process, right? In Google terms, we use something called SLIs, or service level indicators, as a way of measuring the end-to-end availability of a particular user activity. And we use SLOs, or service level objectives, as a term to describe the expectation for how those SLIs emerge in practice for our users, right? And so if you end up with SLIs that accurately measure your users' activities and SLOs that numerically describe what those SLIs should be in a well-running system, you have something very useful, which is a set of measurements that are machine measurable, right? So you can actually measure them constantly, record them, go back and look at them later, alert on them when they aren't working the way you want. And they also allow you to tie the behavior of your system to specific systems, specific components, and specific development teams who are working on the system. And that in turn allows you to manage your development and deployment process, and it allows you to make decisions about how you run your service on a cloud. So if that's all a very abstract concept, let's talk about this in practice. And I'll use, obviously, a made-up example here, but one that we can mostly relate to. So suppose I'm doing an assessment for a banking application. And as you can see on this slide, I've listed the business goals in priority order, right? We have several user activities, and those activities map to business goals, right? For each of those goals, I've mapped out the relevant user activities in my application. And I can see that really my top goal is to retain the customers that I've got. And I know that in order to do that, I need to be sure that the users can conduct their most common and important activities, logging in, checking their account balance, accessing their money, very, very reliably. So for each of these steps, I've defined SLIs, right? And in this case, I've defined that the user flow consists of logging in, right? Accessing their balance, accessing the application to begin with. And I can instrument this with test devices and emulators, and I can break apart the front end and the back end so that I get more fine-grained SLIs. But at the end of the day, the crucial SLI that I'm measuring is this user journey of opening up the application, logging in, and performing the activity, right? And so now I can look at what the user experience is. I can break it down into the sub-pieces of the user experience so that I can tune or debug, and I can have an overall measurement that tells me whether the application is working the way I want it to, and therefore the way that the users will be happy with. Now, there are some other user activities that are described here, and we can see that those are lower priority. It doesn't mean that they're not important, right? Obviously, if we can't sell our users new products, that's very bad for the business. But the reliability requirements for those activities is actually somewhat different, right? For example, if someone applies to take out a loan and there's a problem with the system, it's probably a reasonable result to say, application received and we'll have an answer for you within 30 minutes. Even if you wanted your ideal result to be that the user gets the answer that instant, you'll have relatively low attrition by the short delay, but that covers for a huge amount of downtime, right? 30 minutes a month, right, is not even 4/9 of availability. So this idea of describing and documenting your different user journeys and assigning them an appropriate SLO allows you the freedom to either allocate development resources or allocate money in a way that lets you build a great product for your user rather than focusing on making everything perfect. So with this concept of SLO and SLI described, let's talk about architecture and design and how to achieve those numeric goals for availability. So the first step, obviously, is you'll have to choose a cloud provider or cloud providers, and you'll have to learn how their infrastructure works well enough to know how it can support the SLOs that you've chosen for your own service. So first thing to realize is regardless of which cloud provider you choose, they will also not be perfect, right? That cloud provider will consume part of the unavailability budget that is inherent in every SLO, right? And this would be true whether you were building something on premise or whether you're building it with a public cloud provider, right? And each of them has different services that they offer and different SLOs for those services. And so this is where it's very important for you to look at the services that are provided and the SLOs that are given for those services, and also the SLOs that you could realistically expect if you were to build that same service yourself, right? And questions to ask at this stage, knowing what SLOs you're aiming to achieve with your own application are, does the provider offer infrastructure components that exceed the measured and actual uptime that you've experienced with your on-prem environment, right? Not your targets, but what have you seen in practice? Does the provider offer tools that make the whole stack more reliable, right? Tools that allow you to debug or quickly discover where there are problems, reducing the duration of any downtime that you may have. And does the provider make it easy for you to achieve your desired outcomes with SLOs? And this step really requires some digging and some research, but it pays off hugely because it affects how you build your application and how you deploy your application. And then again, the end result of how your users experience your application. So when deciding which provider can best support your reliability SLOs, you also want to look at the infrastructure that they offer in terms of zones and regions, right? And this is a concept that is now common across all of the public cloud providers. But basically, zones are the fundamental building block of cloud infrastructure, right? They're easy to reason about and they're easy to program for. The analogy is a single data center, right? And like a single data center, they are both well understood and there's limits to how much reliability you can expect from a single zone. So if you need more reliability than a single zone can offer, then you're going to need to run your application in multiple zones or multiple regions. And if we go that route, it's important to understand what you get and what you also don't get from both running in multiple zones in the same region or running in multiple zones in multiple regions. So let's talk about infrastructure unavailability, right? The easy outages and the ones that we often find we're talking with customers about are the ones on the left, right? You picture a data center on fire. It just jumps to mind. Well, jumps to mind if you've been doing reliability for 20 years, so it jumps to my mind. You picture floods, you picture tornadoes, you picture utility power failures. These are the big, very dramatic, very easy to empathize with outages. But in practice, if you look at the headlines from the last 5 years and say, well, what have been the causes of public cloud provider infrastructure downtime? It's actually not any of those things. All of the interesting outages that we see, almost all of the outages, are really due to software or external software events and not these, dramatic, easy to imagine hardware failures, right? So you have network control plane failures, you have global denial of service attacks, you have BGP hijacks, you have authentication system failures, you have configuration changes that went awry, right? None of these things are actually related to any of the hardware. None of them would cause the data center to look like a tornado had gone through it. The data center would look identical. And yet the impact on your service and the impact on that particular zone or region is the same, right? Everything stops working. So, while we're on this topic, we can actually talk a little bit about, current events, right? We can learn from what's happened with the COVID-19 pandemic. With COVID, we saw, another unexpected event that really caused no damage to the physical infrastructure, but caused huge changes in the usage pattern from users. And for here at Google, we saw, for example, huge increases in video conferencing use with our Meet product. And while we were able to scale up and meet that demand through moving resources around, we also saw other instances in industry where demand clearly had surged and the providers or the services struggled to meet the increased demand. And that was, if you will, a failure of scalability or a failure of flexibility, still a logical failure rather than physical failure. But one more example of why sort of the things that you should worry about are not the things that look dramatic or appear in your mind's eye so much as the logical problems that actually are a bit more mundane but really dominate the downtime that we measure when we look at the data. So coming back to this discussion of zones and regions, the bottom line is not that physical failures never happen, yes they do, but rather that they're not actually what the data tells us we should focus on because they are de minimis in terms of their impact on your application, and logical failures are really the thing that we must pay attention to. So for those services that actually require physical separation or physical isolation for example, regulatory reasons, we actually recommend that you look at using multiple regions rather than multiple zones because both regions tend to be physically more distinct than zones, right? Zones on average with public cloud providers are about 10 kilometers apart from each other. Regions tend to be hundreds of kilometers apart from each other. And so you get more physical redundancy for much of the same logical work that's required to make your application run in multiple locations. The other reason that we recommend multiple regions, however, is that on all of the providers, the logical isolation that you get between different regions is significantly higher than the logical isolation that you get between zones in the same region. So in practice, what we see is that an application that runs in multiple regions will have many fewer logical failures that it's exposed to than an application that simply runs in multiple zones inside the same region. Okay, so at this point, you've got your user journeys described, you've got your SLOs, and you're working on this question of should I use multiple zones or should I use multiple regions, or is a single zone sufficient for my needs? You also at this point want to consider how easy the provider makes it to deploy instances of your application across multiple locations, whether it's zones or regions. Generally, all of the public cloud providers offer regional versions of their services that automatically distribute the data and processing and user traffic across multiple zones in a region. And you can use their offering or you can roll your own, but generally, what we would recommend is that you use the version of those tools provided by a provider for two reasons, right? One is they have many more flight miles on them than whatever you're going to build yourself. And two is you benefit from all of the other customers who are also using those tools, and therefore the investment that the cloud provider will be making in improving those tools over time. And we've seen that there's a temptation to look at those systems and say, well, they haven't been perfect, so I should build my own because I know I can build my own perfect system. But actually, as experienced professionals, we all know that building your own version of a multi-zone, highly available, highly performant system is actually quite tricky. It's both expensive in terms of development time, and it's difficult to get right, and then you'll have to maintain it and improve it for forever. So I would encourage you to, by default, use the tools that are provided to you rather than rolling your own in cases where those tools are available. So if you look at the building blocks, again, that cloud providers offer you, we can see here in this example map, right, sort of three basic options, right? You can run a service in a single zone, represented by one of those circles. You can run a service in several zones inside the same region, which still means you're in one of those circles again. Or you can run your service in 2 or 3 regions using one or more zones in each of those regions. And you can see, right, that the separation that you get physically is quite large between regions. So there will be increased latency between the regions, but also there's a great deal more physical isolation that's provided by the regions. And then, as I mentioned, there's also a great deal more logical isolation. And here again, it's important to look at the provider or providers that you're using, right? Because different providers do it differently. I won't spend time talking about the other cloud providers, but in the case of Google Cloud, we do offer features that make running in multiple regions much easier. For example, we have single global interfaces that allow you to view and manage the resources that you've got. We've got products that automatically will allow you to select a multi-regional offering and that do data replication and data processing across multiple regions. And then we have a very large, very high bandwidth backbone network that allows you to transfer data between regions and do load balancing to distribute your traffic across multiple regions. So putting this all together, what do you want to look for in a cloud provider, and how do you want to think about your own architecture for a cloud provider, right? I would say first and foremost, you should ignore the marketing and look at the data. The performance data from the different cloud providers is different, and each of them has some pros and some cons, and you want to look at how those pros and cons would affect the application that you're trying to run and the availability targets that you've chosen for yourself, and pick one that's the best match for your particular needs. I would say, secondly, you want to look at the strength of each provider in terms of their infrastructure security, right? Infrastructure attacks themselves are a reliability problem. If there's a DDoS, no one really cares whether it was your application or your provider's infrastructure that failed to protect you, right? All the users will know is their application stopped working and they're angry with you. And so it's important to look at the track record of dealing with large-scale attacks and large-scale security challenges and make sure that the infrastructure providers that you are using meet your needs in those regards. You should look at the size, maturity, and scalability of the provider's infrastructure. Again, picking on denial of service attacks, right? Those attacks tend to be very large. There are public reports of attacks in the multi-terabit range. And so size does matter and scale does matter. And picking providers that have both the resources and the track record to be able to absorb very large attacks when they happen will give you a degree of security and protection that you otherwise wouldn't have. Or similarly, if there's been a major shift of demand as a result of, for example, COVID, right? Does the provider have the experience and the track record of being able to continue to provide resources for your application when and where you need them, despite this unusual surge in demand? You should consider as well how easily your architects and developers can design, build, and deploy on the infrastructure that your cloud provider offers, right? How easy is it to build a system that spans multiple zones or multiple regions? And how much work do they have to do to maintain or roll their own systems for places where the infrastructure provider does not offer the system that you need? And then finally, definitely, if you have an application that for regulatory reasons or other reasons requires physical separation, you should look at the physical location of both data center zones and data center regions in order to pick a solution that appropriately balances the latency of zone or region separation with the physical and logical protection that you get from that separation. And you should do all of this with an eye back to those SLOs that we talked about earlier. How do I achieve my SLOs with a minimum of overhead and therefore a maximum of development and feature velocity? So let's now move on to part 3, which is how you can implement and operate a reliable application. right? This section is specifically about what you can do in your own stack to take advantage of cloud and also to reduce the risk of the outages in your own code base. And these techniques build on the steps that we've talked about so far, using service level indicators, using service level objectives, measuring them, and selecting a cloud provider that gives you the performance and flexibility that you want for your own application. So within Google, in addition to thinking about reliability as how do we minimize failures, we also think about how do we make our service resilient to the sorts of failures that we're likely to see when they do happen. And we spend as much time on systems here at Google which respond to failures and mask them from our users as we do in preventing those failures in the first place. And this principle that failures are normal, that we want a good user experience despite a small but continuous level of failures in systems, pretty much affects all the phases of system design, development, and deployment. So I'll talk about two of the most important areas there, architecture and design, and then deployment and operation. So for architecture and design, we recommend taking a skeptical position, right? And choosing an architecture which breaks your stack into components. Those components can be decoupled from each other, they can be moved around, they can be scaled up and down. And this is something that cloud makes it very easy to do, right? Cloud already offers scalable and flexible capacity. It offers multiple independent zones and regions. If you have a modern application design using microservices, right, we have products like Anthos that make it easy to make components mobile, to scale them, and also makes it easy to detect problems with individual components and hone in on them. If you have a more traditional application that runs in virtual machines, Google Compute Engine has managed instance groups which give you a similar level of flexibility. And finally, the idea of getting resilience through failure detection and failure minimization is a key concept, right? If you have load balancing that can shift traffic between different pools of instances, then you can send small amounts of user traffic, for example, to a new version of the application and verify that those users are getting the result you expect before you increase the fraction of your application that uses that new version. And that way you can seamlessly roll users over to a new version of the application without ever putting too many of them at the risk of a new release at once. And if it isn't working the way you expect, you can just send all of your user traffic back to the existing instances that you've got of the version of your application that you know works, and then you can debug what went wrong at your leisure without time pressure. During development, cloud also offers a number of powerful tools to support best practices like continuous build and testing. For example, it's very easy to spin up a whole new test instance of your production application that's decoupled from your actual production environment. And there you can test new versions of components, make sure everything works together, do an integration test, and spin it back down. And that way, by the time you actually deploy to production, you have a great deal of confidence that the application is going to work the way you want, and you've taken advantage of the same concepts of component groups and scaling that you'll use in your production environment. So when we talk about deployment and operation, I think of the different areas of reliability, this one often gets less attention than it ought. And I'm not just saying that because I've spent the last 2 decades of my life working on deployment problems. But for two reasons, really. Primarily, that the impact of a change on an application is somewhat underappreciated. Most failures that we see occur during attempts to change an application. It's the single largest cause of outage, and yet it's not the place sometimes where we spend the most time making sure that our practices are safe and appropriate to the reliability targets that we've got. And secondly, because change management is actually hard, and historically, it's been difficult to be sophisticated about change management. It can be treated as sort of a monolithic. We have the old version, we have the new version, we have a failover period. And that approach is very, very high stakes. You have to get everything right with the new version or you have a catastrophe. And so really, when we think about deployment and operation, it is a place to take advantage of a lot of the capabilities that cloud gives you to drastically reduce the risk of deployment and the risk of new versions. And that in turn means that you can deploy much more frequently and you can have higher development velocity and eventually then more features for your users, which is obviously a highly desirable trait. So a few tips, and this is a deep area, so I'm just going to scratch the surface, but shameless plug for the SRE book if you want to read a lot more about this. In general, the best way to manage a change and thus minimize the risk of a change-related outage is, first of all, to practice progressive rollout. Right? And progressive rollout means that you apply updates to instances of your application either in different zones and regions independently or to small fractions of your instances first and then greater fractions as you gain confidence that everything is working the way you expect. And cloud infrastructure supports you here, both with automated development tools, but also with automated deployment tools. Supervision of rollouts is very, very important, and supervision in particular means knowing what you expect to see and only continuing with a rollout if the results are exactly what you expect, right? No more, no less, no different. A lot of times what we see with rollouts that have gone bad is they weren't overtly failing, but they weren't behaving the way that we expected. And the criteria for continuing had de facto been, well, unless it's breaking, keep rolling out, right? And that masks things like, oops, we're consuming 6% more memory than we had expected, which is fine at the time you're doing a rollout during a local trough of traffic, but the next morning when peak traffic rolls around, it turns out that's a problem, right? And so this idea of knowing what to expect and only proceeding with a rollout when it's working the way you expect gives you a great deal of safety for really extremely low cost. And then in addition to rollout, obviously, if things aren't working well, your rollbacks need to be fast, safe, and easy, right? Some of the outage postmortems that we've done, one of the reasons that the outage occurred was that the team that was in the middle of the rollout was nervous about rolling back when the system wasn't behaving the way they expected. And that has a predictable result, right? If your rollbacks are fast and safe and your application was working before you started changing it, right, then hitting the big rollback button the first moment that something isn't going the way you expect becomes habit for everyone, and that actually will save you from a ton of avoidable outages. And then finally, designing your application so that it fails in a way that gives you a reasonable result. We call it fail static. But things like, you get a configuration change and you send that configuration change to the first instance of your app and that instance of the app stops responding, right? For whatever reason, maybe it's crashing loop, in the crash loop, maybe it's just not able to parse the configuration, whatever. The application at that point can say, well, I'm not sure what's going on, but I know that I was working fine before this change started, so I'm just going to stop applying changes to the app, fail static, and fire an alarm that asks the human to come and look for me. And this idea of fail static can save you from a great number of unexpected behaviors during a rollout or during a change with essentially no cost again to your user because the application just continues to work the way it used to work. And cloud can really help you in a number of these practices because it offers scalable infrastructure so that you can spin up and spin down instances. During a rollout, you can have extra capacity to run both new and old side by side, for example. It allows you to test, it allows you to monitor the behavior of your application, and it gives you insights into the behavior of individual components so that you can look at, is it working the way it used to work, not just at the SLO level for your user journeys, but actually at the component level. And this gives you a great deal of safety. So in summary, that was a whirlwind tour of reliability in the cloud. It's, like I said, my life's work at this point. And it's a very, very deep topic, but we have at least covered a number of the most important and most salient points for building and running reliable applications in the cloud. And my goal today really was to give you a framework about thinking about these three major steps in your cloud reliability journey. And then for each of those steps to give you some specific ideas to get you started down the process of more detailed planning. Developing for reliability in the cloud can require some new thinking and a change in perspective, but it also gives you a great deal of flexibility and a great deal of power And I can assure you from experience, it is a step function, right? Once you've looked at building reliable applications this way, you won't look at them in the old way very often anymore. And I hope this has been helpful for you both in thinking through that process, thinking through assessing your application and your measurable availability goals, thinking through how to select a public cloud provider or providers, and leveraging the systems and tools and structures that they have available to make your application more reliable. And finally, to help you think about architecture, design, deployment, and operation of your application to anticipate and work through a wide reliability challenge suite, including reliability challenges that are triggered by your own actions, as well as those that may occur as the result of exogenous events. Thank you so much, and good luck to everyone.